We're building this incredibly smart, connected world, from our cities to our energy grids, and especially the factories that build, well, everything. It's all coming online. Now, this promises a future that's super efficient, but it also creates a massive new challenge. How do we secure all of it? Let's dive in. And this is the reality of what's called the Industrial Internet of Things, or IIoT. It's this amazing network of sensors, machines, and systems that's driving modern industry. But here's the hidden danger. Every single one of those connections, from the robot on the factory floor all the way to the corporate server, is a potential doorway for a cyber attack. The very thing that makes these factories so smart also makes them incredibly vulnerable. So we have this amazing world of smart things, which on one hand is fantastic for productivity, right? We can watch assembly lines in real time, predict when a machine needs fixing, and make entire supply chains run smoother. But connecting everything from a tiny sensor to a massive cloud server, well, that creates all new kinds of dangers at every single level of the system. And look, the stakes here, they couldn't be higher. A security breach isn't just about someone stealing some data. We're talking about shutting down an entire factory, causing massive operational downtime. It can mess up global supply chains, lead to the theft of priceless company secrets, and in the worst-case scenario, it could even threaten the physical safety of the people working there. And here's the real kicker. The old ways of doing things just don't work anymore. Just try to imagine managing a unique username and password for millions, maybe even billions of little devices. It's basically impossible. And it creates these single points of failure that are just begging for password leaks and cyber attacks. We really need a fundamentally new way to think about this. And that new approach, it might just be blockchain. But we're not just talking about some flimsy security patch here. This is a completely different way of building trust into the very foundation of the network itself. Think of it like designing a building to be earthquake-proof from the very beginning, instead of just trying to nail boards over the windows later. So what is blockchain really? At its heart, it's just a digital record book. But here's the magic trick. Instead of one person holding on to that book, everyone in the network gets their own identical copy. And once a page is written in that book, it can never, ever be changed or erased. It's a powerful idea, and it's what makes this whole thing so revolutionary. Okay, so take a look at this. This shows you how that unbreakable part actually works. Each new block of data gets sealed up with some heavy-duty cryptography, and then it's linked to the block that came right before it. This creates a chain where messing with even one link would mean you'd have to rewrite the entire chain's history, which is practically impossible. And that's where the incredible security comes from. So these three things right here, this is the secret sauce for securing the industrial Internet of Things. Decentralization means there's no big central server for hackers to aim at. Immutability guarantees that all the data is tamper-proof. And transparency, that gives everyone on the network one single trusted source of truth that they can all see and verify for themselves. Okay, but it's not all smooth sailing. A regular off-the-shelf blockchain is great, but industrial settings need more. They need things to happen fast, and they need to keep their sensitive business data private. And this is where researchers cooked up a special innovation to fine-tune blockchain for the factory floor. So this brings up a couple of huge questions, right? First, how can you prove a transaction is legit, like, say, that a machine part meets certain standards, without shouting all the sensitive details of that part to the whole network? And second, can you do all that checking and verifying in milliseconds, at the kind of speed you need for a factory to run smoothly? All right, the first part of the answer is something called a zero-knowledge proof, or ZKP. It's a really cool bit of cryptography. Think of it like this. You can prove you have the key to a house by describing some unique object that's only visible from inside, without ever actually showing anyone the key. You prove you know the secret without revealing the secret. And the second part of this solution? That's a trusted execution environment, or TEE. This is basically a super secure vault built right into a computer's processor chip. Any code or data you put inside that vault is totally locked down and protected, even from the computer's own operating system. It's a hardware-level guarantee of security. So, you can probably see where this is going, right? Researchers had this brilliant idea. What if we combine these two things? They merge the privacy of zero-knowledge proofs with a hardware-level security and speed of a trusted execution environment. And the result is a brand new, powerful algorithm they call TEZKP, built just for the demands of the modern factory. Okay, this diagram might look a little complicated, but let's just walk through the story together. It's actually pretty straightforward. A sender starts by encrypting their transaction data. Then they use that zero-knowledge proof to create a mathematical proof that the data is valid, all without revealing what the data actually is. That proof then gets processed inside that ultra-secure hardware vault, the TEE. Finally, this secure little package gets sent to the blockchain. The person on the other end can then quickly verify the whole thing and unlock the information. The process looks complex, but the result is simple: a transaction that's fast, private, and incredibly secure. All right, so all of that sounds fantastic on paper. But the real question is, does it actually work in the real world? To find out, researchers set up a bunch of simulations to put their new algorithm head-to-head against other leading methods. And wow, the results were pretty stunning. This chart here compares how long it takes to generate one of those security proofs. As you can see, that purple line, which is our new TEZKK algorithm, is way, way lower than all the others. And that kind of speed is absolutely make or break for real-time stuff happening on a factory floor. Let's put a number on it. Even when the system was under a heavy load, the TEZKP algorithm got the job done in just 352 milliseconds. That is literally faster than the blink of an eye, and it's a massive leap forward from older methods. It's what makes this whole idea actually viable for high-speed industries. So let's just wrap up what the tests told us. The TEZKP system was way faster at creating the proofs. It was right up there with the best when it came to verifying them, and it did all of this while keeping everything super secure and private. It's that combo of all three that makes this such a huge potential breakthrough. Okay, so we've geeked out on the tech, we've seen the data, but let's pull back for a second. Why does any of this matter beyond a research lab? What does it actually mean for our future? Well, the implications are just huge. This isn't only about factories. This kind of fast, private, and decentralized security could become the backbone for our entire connected world. We're talking about securing global supply chains, protecting our power grids, building smart cities we can actually trust, and even making sure our connected healthcare devices are safe. And you don't just have to take my word for it. The researchers behind this work put it perfectly themselves. They said that blockchain tech provides a new solution for security in the Internet of Things. It's a total shift away from those old, vulnerable security models and towards a system that's spread out, resilient, and fundamentally trustworthy. So I'll leave you with this question to think about. As we connect every part of our lives and our industries to the Internet, we're building a world that literally runs on data. And in that world, what's the one thing we absolutely cannot afford to lose? It's trust. The challenge for all of us, going forward, is to make sure that trust is built into the system from day one.